Now comment 908 tells you that there's two ways to show that your value is a maximum or minimum. These are shorthand ways. If you really want to show that something is a maximum or minimum, just draw the graph of the whole situation. So for example, this curve has a minimum at 0, 0, at 1, 0. Well, if you draw it, I meant 1, -1, then you'll see it there. So what I'm talking about is shortcuts to save you having to draw the whole graph. Well, as it says in the comment, and you can look up separate videos on these, there's two ways. One is a derivative table, where you take your point that's in the middle, go a little bit to the left, a little bit to the right, substitute into the derivative, you get 0 where it's flat, and you get a number out to the right. Let's say that's, I don't know what it would be, I think it's 2, and then over to the left it's -2, and you draw that going down, flat, and then up. So that's your minimum. Or you can find a second derivative, which for this would be 6x, and you substitute into that, which at x equals 1 is 6, and you say therefore positive, therefore minimum. Why does that work? Because a second derivative mentions concavity. If something is concave up, then what makes it concave up is that it has this bottoming out point there, which is why you're able to say that it's a minimum. Anyway, as I say, there's separate videos on this. So for example, I think it would be called Determining the Nature of a Stationary Point. Comment 908 just reminds you that there are two fast ways to do this. A first derivative table and a substitution into a second derivative.